guys that just came in, I have a sheet up here for you. Make sure you sign the thing that's going around the attendance thing. Okay, you need one, you need one, you need one. 3 of them. That's what's on the screen. Okay, so we're on the page 2. Here's what a cardiac muscle cell looks like. Okay? Now, unlike skeletal muscle cells, skeletal muscle cells are arranged like this. I'm sure you remember this from 27. These are skeletal muscle cells. Right? Very distinct. How about smooth muscle cells? Well, smooth muscle cells look like this, and they tend to overlap to some extent. Okay? But cardiac muscle cells look like a web. Okay? Now, so where are the cells? Here's 1, here's 2, here's 3, 4, 5, let's see, 6. So, here is number 2. This whole thing here, that's number 2. This whole thing is number 3. You see, they're not lined up like this. If I stimulate this skeletal muscle cell, then the impulse goes in that cell. The only way I could have both of them contracting is to literally stimulate them all at one time. Up here, if I stimulate this thing, I'm going to stimulate that cardiac cell. The impulse is going to go from here to here to here to here to here, etc. It's going to go to all of them. Why? Because they are so close together. This thing here is called an intercalated disc. People thought for years that it was actually something in between the cells. Tell, they got very powerful microscopes and saw that in between cardiac muscle cells is not a disc, but it's like this. Cell membranes overlap. So here would be 1, here would be 2, and so forth. So when we're looking at this ordinary microscope, it looks like a dark band. But when we enlarge it, see that it's actually the membranes overlapping. Because they are overlapping and they are so close to each other. And here I have an impulse going along here. That impulse is just going to go right to the next cell. No neurotransmitter, etc. in between. So when I stimulate this thing here, this whole thing is going to contract. Because the impulse is going to move from here to here to here to here almost instantaneously, as if it's one big cell. All right? So, what's the big advantage of that? Moves directly from one, impulse moves quickly from one cell to the other in various directions. Now, that's the key also. Is it moving only in one direction? Well, it depends on where I stimulate it. If I stimulate this cell here, then it's moving this way and that way. And of course, down this up. If I stimulate it only here, then of course it's moving in that direction. But it depends on where it's stimulating. But, key thing, it's moving very fast. Is it moving faster than in other types of tissue? Not necessarily, but it's moving directly from one cell to the other cell. Mass of cardiac muscle acts like a single cell. All right. And what's going to happen to that single cell as that impulse moves? There's 2 things going to happen. There's only 2 things going to happen here. Now, what kind of condition is it in to begin with?
Polarized.
It's polarized. That means the difference in charge between the outside and the inside. So there's only two things can happen. It's going to switch around, quote, depolarize, and then switch back where it was first. Just like the single cell we talked about a minute ago. So, that single mass is acting like a single cell. So, depolarize and then repolarize. Go back. The ventricle, you know, of course, that the heart has what? Two ventricles and two atria, right? Everybody forget that one? I think it was on the test last week. Huh? It's already gone. I've seen that before. I've seen that a lot of times before. Okay. I had a lecture test one time, some years ago. People did very well. I think the average was like 80. And I asked them some questions the next period, and nobody could answer. They put it in there, answered the test, and gone. Okay.